Okay, let's have a look at the theory in exercise 7b, which relates to the angle properties of triangles. So what we remember is that the sum of the angles inside a triangle is 180 degrees. So triangles can be classified by their side lengths or by their internal angles. So they're classified by their side lengths. That means whether they have three sides the same, two sides the same, or no sides the same. If there are three sides the same, they're equilateral. If there's two sides the same, they're isosceles. And if no sides are the same, so one side is the same, you might say, then they are scalene. They can also be classified by their internal angles. So if all of them are less than 90 degrees, they are called acute angled triangles, all three. Okay, and then, as we know, they add up to 180 degrees, and there's three of them. So if we get to a right angle of 90 degrees, the other two have got to be acute. We call it, if there's one right angle triangle, we call it a right angle triangle. And then if it hasn't got a right angle, but if we have got one angle which is bigger than 90, it is an obtuse angled triangle. So we couldn't have an obtuse angled isosceles triangle because the angle which is not equal is bigger than 90, and then the other two are equal and smaller than 90. We can have an acute angled isosceles. We can have a right angled isosceles with 90 and 245s. We cannot have anything but an acute angled equilateral, because with equilateral they all have to be equal to 60. So an equilateral triangle is an acute angled triangles. Scalenes can be anything, because all it means is that the sides aren't the same length. So we can have acute ones, obtuse ones, or right angled ones. Now the other theory that they're doing here is exterior angle theorem. So it's saying that the angle out here, the exterior angle x, is always equal to the sum of these two, a plus b. And that's very simple for us to prove, because we can see that this thing is 180. That's equal to 180 degrees. And that's that angle plus this one. So also in here, our triangle is equal to 180. This one, which is equal to this one, plus those two. Since this one's in the sum of both, this one has got to be equal to those two. So that's our exterior angle theorem. It's just stating the obvious. They've got 180 degrees in a straight line, and this angle next to here is the other half of the angle that goes in a straight line. The angle inside the triangle is 180, therefore these two here are equal to this one out here. Let's have a look at a few problems. Using the angle sum of a triangle, find the value of the unknown angle. So I've got 180 is equal to x plus 55 plus 85 equals x plus 140. And if you're doing our equations, all that sort of stuff, we can subtract 140 from both sides. So if we do that, we're going to get 40 is equal to x. X equals 40. You can also do that by inspection. All right, so an isosceles triangle. We want to find the x in this isosceles triangle. Now they've told us that these are the two angles, or the two sides are equal. That means this one is also x. So we know that x plus x. So x plus x plus 40 equals 180. 2x plus 40 equals 180. If we subtract 40 from both sides to get rid of it from that side, 2x equals 140. Divide through by 2, x equals 70 degrees. And our last one, using the exterior angle theorem, it wants us to work out what x is. Now, as we already said from our triangles, We know that x plus this angle, that little dot in there, is equal to 180, and 95 and 150 plus that dot in there is equal to 180. So our x is equal to 50 plus 95 equals 145 degrees. Looking at this one here, it's looking for us to find the value of x using the exterior angle theorem. And so what this has got in here, these things here have the same symbol. Therefore, they are therefore they're not equal. Anyway, we'll use an exterior angle. Our exterior angle is 70. That's equal to the two opposite sides, so it's equal to 30 plus x. Subtract 30 from both sides. 40 degrees equals x, x equals 40 degrees. All right, have a go at the exercises on your sheet that relate to this.